Uh, Welcome to the final session of the fifth module and even the final session for the subject Elements of Mechanical Engineering. We have studied the different machine tools and even the numerical control and the importance of this computer numerical control and how different from the basically numerical control systems. So in the last chapter and the last topic which is there left out is robotics. Basically, a robot is one of advanced machine which has been introduced by this humankind, which does the work all the machine tools, and also it can also be called as the one of the intelligent machinery that has been invented by the humankind. So basically, this robot, as particularly applied to the industrial robot in general, is defined as an industrial robot is a general purpose, a programmable machine processing certain anthropomorphic characteristics. The most obvious anthropomorphic characteristic of an industrial robot is its mechanical arm, which is used to perform the various industrial tasks. It can also be defined as an industrial robot is a multifunctional. It is a multifunctional. That means it cannot designed only to do a particular task, and it can be used for a multifunctional task. Okay, it's a multifunctional manipulator which has been designed in order to do a specified task. That is what we define. That is how we just define it as an industrial robot or a general robot. Other human-like characteristics are the robot's capabilities to respond to sensor inputs, communicate with other machines, and make decisions. These capabilities permit a robot to perform a variety of useful tasks. The development of robot technology allowed the development of numerical control, and the two technologies are quite similar, whether it may be numerical control or the robots. The trend of work has been similar. They both involve coordinate control of multiple axes, that is the axis called as the joints in robots, and they both use dedicated digital computers as controllers. Need not be even in the robots that we should have a robot actually, that means a computer. Even whatever the motherboard or the data input that we provide it, in case of a computer, the only that motherboard can be installed in the robots. The robots are designed for a variety of wider tasks. Typical production application of industrial robot include a spot welding, material transfer, machine loading, spray painting, and assembly unit, and even the pick and place operations also. And most of all, even these robots are also used in the inspection system also. Some of the qualities that make the industrial robots commercially and technologically important are being listed over here. Robot can be substituted for humans in hazardous and uncomfortable work environments. So, for example, in a nuclear reactors, where these nuclear radiations will certainly affect the humankind in such kind of environments, and the uncomfortable environment may be very high temperature, very cold temperature it may be, and maybe the places where the oxygen absence is in. These are in such kind of uncomfortable work environment, or if it is a monotonous. Say for example, if I want to pick and place a one sample from one place to the other place, it may be easy. The same the 100 numbers, if it is 1,000, if it is a lakhs together. So it is not possible by the human kind. It is only because a monotonous work can be performed with more accuracy and precision by these robots. A robot performs its work cycle with a consistency and repeatability that cannot be attained by humans. Robots can be programmed when the production run of the current task is completed. Okay, a robot can be reprogrammed and equipped with necessary tooling to perform an altogether different task. Robots are controlled by computers and can therefore be connected to the computer systems to achieve a computer integrated manufacturing. And this is simply also popular, we call it as SIM, that is computer integrated manufacturing. We are making an advanced manufacturing system by the integration of computers. Robot anatomy. This is basically, as we have two hands and so much of limbs are also there in our human body, even the anatomy of a robot will have a similar sort of joints with different degrees of freedom. A manipulator of an industrial robot consists of a series of joints and links. If you consider this hand, this is a link, this is a joint. Okay, now this is a link, this is a link, and this is the joint. Now here once again it is a joint and this is a link. So similarly, the robot anatomy is concerned with the type and size of these joints and links and other aspects of the manipulator's physical construction. Let us see what is this anatomy has. Most robots are connected on a stationary base on the floor. Let us refer to this base and its connection to the first joint as a link 0. And that is what I have just shown in the next step. Now this is a base. With reference to the base only, all the links and joints have been formed or it has been designed. In such cases, an end of arm is also called as an end effector. Now the base, the one which supports and it balances the complete link 0, link 1, link 2, and then the joint 1. Joint 1 which connects link 1 and link 0. And then the joint 2 connects the link 1 and link 2. That is what is been explained over here. Now, let us refer to this base and its connection to the first joint as the link 0. It is the input link to joint 1, the first in the series of joint used in the construction of the robot. The output link of the joint 1 is link 1. Link 1 is the input link for the joint 2, whose output link is link 2, and so forth. It keeps going. Nearly all industrial robots have mechanical joints that can be classified into one of 5 types. 2 types that provide translation motion and 3 types that provide a rotary motion. These joint types are illustrated in figures. The 5 joints types are there are 5 different types of joints are there. One is a linear joint which is denoted by L. The relative movement between the input link and output link will be a translational sliding motion with the axis of the 2 links will be parallel. Now that means the link, the first there are 5 different types of joints are there. In the linear joint, what happens? The movement will be in a translation. That means it will be in a parallel way. Now here you can see this. Okay. Now each joint, this is nothing but this is a joint and this is a motion. Input and output. This is in a translation. Is it clear? Next one, is a joint with, this is also translation sliding motion, but the input and output links are perpendicular to each other, where the input and output, this is an output and this is an input, where the moments are perpendicular to each other. This is a rotational one, rotational joint, which is denoted by R, whereas the orthogonal joint is denoted by O. L is a translation or a linear joint. Is it clear? Now, this is a rotational joint. This type provides a rotational relative motion with axis of the rotation perpendicular to the axis of the input and output link. Twisting joint, type of T joints. This joint also involves rotary motion, but the axis of the rotation is parallel to the axis of the two links. Now this is called as a twisting joint, something like a twisting joint. Is it clear? No, this is a twisting joint. It is denoted by T. R is for rotational joint. Each of the joint types has a range over which it can be moved. It is something like even our hands also. I can make this a rotational one, even my shoulder joint also. But it is being constrained with the restricted. I cannot make this completely backside. It is because it is restricted. It is constrained. Okay. Within a constrained movements, these can operate it. Classification based on robot configurations. Industrial robots are designed to have various arm manipulations so as to have motion in different directions. The possible types of arm movements that a robot is designed with defines configurations. A robot can have any one of the following configurations. One is a Cartesian coordinate configuration, second one is a cylindrical configuration, third one is polar configuration, and the fourth one will be jointed arm configuration. SCARA is one selective compliance assembly robot arm. Okay, now this is not there in the syllabus. Basically these four types: Cartesian, cylindrical, polar. Polar is also called as a spherical configuration, and then we also have a jointed arm configuration robots. The Cartesian coordinate Cartesian coordinate configuration robot will be as shown in the figure. Actually, as the name itself indicates, the motion of the robots is restricted in a translative motion. Okay. That means there is no curvature motions, there is no rotational motion, there is no revolving motions. Only thing is it can move in x and plus x and minus x direction, plus y and minus y direction, and plus z and minus z directions. That means it will move only in 3 x, y and z coordinate system. That is what I shown it in figure. Now here you can see this even in the figure x. This link, x link, can move in and out, whereas the y can move in and out within this link, and z, it is the up and down movement of the z. So that is an x, y, z axis of the coordinate systems. So even if you draw it, the maximum limits, it forms a cube. Okay, the Cartesian coordinate configuration robot is also called because the arm movement of the robot is designed to move parallel to x, y and z axis of a Cartesian coordinate system as shown in figure. A robot designed with this type of configuration capable of moving its arm to any point linearly within a rectangular workspace. Since the arm movement is linear, the robot is called as rectilinear or gantry robot. This is the beauty of that. Okay. Now the next one is advantages. It is simple control due to linear movements and also easy visualize. High degree of mechanical rigidity, accuracy and repeatability. It is able to carry heavy loads. Movements can start and stop simultaneously along all three axes. Motion of a wrist end is smooth, whereas the disadvantage is the arm movement is limited to a small rectangular workspace, occupy large space. because it doesn't move in curvature. So it should be low ratio of robot size to operate volume. And then applications wise, it is used in assembly, welding, machine loading and unloading, surface finishing and inspection, etc. are few applications of this Cartesian coordinate systems. Then the cylindrical configuration robot. A cylindrical configuration robot combines both vertical axis. I just shall show you over here, then you can talk to it. Now here also we have got the three motions. One is at the base. You please carefully see here. At the base we have a rotation axis. That means it can rotate like this. 360 degrees it can rotate. The vertical, as shown it in the Cartesian coordinate, it has got a vertical, that is a z axis. It can move up and down. And then as we have shown there, even it has got a y direction also. It can have a y direction, x, y, z and y direction. Instead of x we have a rotation motion. So the workspace what it can make will resembles a cylinder. So only it is called as a cylindrical coordinate system. A cylindrical configuration combines both vertical z-axis and horizontal x-axis. The linear movements with rotary movements in the horizontal plane about a vertical axis. It is also called so because its motions sweep out a partial cylinder working volume. This robot configuration finds application in radial workplace layout where the work approached primarily in the horizontal plane and where no obstructions are being present. A typical cylindrical configuration is been illustrated in the figure. It consists of a base and a horizontal arm and a prismatic joint built into horizontal around the vertical column. Describing a partial cylinder in space, the prismatic joint can slide in and out, remaining parallel to the base. This is the one. This is the work envelope or a profile that is being generated volume. Larger workspace than it has got a larger workspace than Cartesian configuration. Robot is relatively easy to program. Applications comes to be machine loading and unloading, investment, casting, and then forging, operations and conveyor, pellet transfer, assembly, and then the coating applications. Polar coordinate configuration or a spherical configuration. The geometry of the spherical or a polar configuration combines rotational movement in both horizontal and vertical planes with a single linear movement of the arm. This configuration occupies and sweeps out a relatively large volume and axis of the arm. Within this total volume is been restricted. This robot rotates about the vertical axis. T-joint, that is translatory motions of twist on the base, and second axis is a horizontal rotary joint, that is a rotational joint, or allowing the arm to rotate in a vertical plane, making use of both axes. The arm can sweep through a partial sphere of radii depending on the length of prismatic joint L. This is the beauty. This is the base, the one. Now about its base axis, it can rotate, which provides a rotational traverse, and then there is a radial traverse which can rotate up in perpendicular. It is something like it can rotate and it can vertically traverse, something like this. It is something like this. It can vertically traverse, and then radial traverse, rotational, radial and vertical traverse. All the three are there. So if this work volume is nothing but the volume or the area within which it can work, so that resembles a partial sphere. So this is called as a spherical or polar coordinate system. Advantages is being a simple in design and hence easy to program. Provides a good weight lifting capabilities. It is extensively used in die casting, injection molding, forging, machine tool press and material transfer applications. And the final one is a jointed arm. It is called as a jointed arm because it, if you see this now, that is what even I have given. This is a shoulder, and this is an elbow, and this is the wrist. Got my point? This is the upper arm, and this is the forearm. Now this is the upper arm. You can see this. This is the shoulder. This is the shoulder. This is the shoulder, and then this is an elbow. It resembles a human arms. So that is the reason why this robot manipulator has a general configuration of a human arm consisted of two straight components corresponding to the human forearm. This is the forearm, and then this is the upper arm. Okay, now this is the shoulder. The shoulder, upper arm, and then forearm. This is the one link, and this is the other link, and this is the wrist. Is it clear? Now, the jointed arm consists of a vertical column that swivels about the base using a T joint. At the top of the column is a shoulder joint, or which can be rotated like this. Is it clear? It is rotated like this, and this can be translated. And then whose output link connects to an elbow joint, which also have a rotational joint. Now you can see this. Here it is a rotational joint. Here also it is a rotational joint, and here also. This is the wrist. My dear friends, this wrist end can be connected to any specified task. Say for example, if you want to use this robot for a painting, you can fix a painting gun at the wrist end. Is it clear? Advantages of robots. Robotics and automation can, in many situations, increase the productivity, safety, efficiency, quality, and consistency of product. Robots can work in hazardous environments. Robots need no environmental comforts. Robots work continuously without any humanity needs or and illness. Obviously, robots can repeatedly precise at all the times. Robots can much more accurate than humans. It will be accurate much more than humans. They may have a milli or micro inch accuracy. Robotics and their sensors can have capabilities beyond that of humans. Robots can process multiple tasks, can do a multiple task simultaneously, but human can only one. Robots replace human workers who can create economic problems. That is true. Disadvantages of robots. Robots are lack the capability to respond in emergencies. This can cause an inappropriate and wrong responses, a lack of decision making power, a loss of power, damage to the robot and other devices, human injuries may be needed. Robots may have limited capabilities in degrees of freedom. That is the freedom, the movement of the arms, and dexterity, sensors, vision systems. Real-time response robots are costly due to initial cost of equipment, installation cost, need for peripherals, need for training, and need for a program. It just follows the instructions, and it will not have its own mind of thinking. The basic robot motions, whatever the configurations may be, the purpose of the robot is to perform a useful task. To accomplish the task, an end effector or a hand is attached to the end of the robotics arm. It is the end effectors which adapt the general purpose robot to a particular task. To do this task, the robot arm must be capable of moving the end effector through a sequence of motions and positions. There are 6 basic motions or degrees of freedom which provide the robot with the capability to move the end effectors. End effectors, they are nothing but which is been attached to the wrist to do a particular task. It can do a drilling operation if you fix a drilling spindle to them. Okay, that is what we call it as an end effectors. Through the required sequences of motions, these 6 degrees of freedom are intended to emulate the versatility of movement possessed by the human arm. Not all the robots are equipped with the ability to move in all 6 degrees. The six basic motions consist of three arm and body motions, and the three wrist motions, arm and body motions, which leads to six motions. Okay. Three body motions are the up and down movement of the arms caused by pivoting the entire arm about a horizontal axis or moving the arm along the vertical side. Radial traverse, extension and retraction of the arm in and out of the movement. And then rotational traverse, rotation about a vertical axis, right or left swivel of the arm. Wrist movements are very important. There are three wrist movements. One is the wrist swivel. A rotation of this wrist is not nothing but wrist swivel. Okay, now here itself we can make it up. This is wrist swivel. Next, wrist bend, up and down, up and down. Movement of the wrist. This also involves a rotation movement. Then the wrist yaw, right and left, right and left. This is called as a wrist yaw. Okay, that can be shown here in this figure. Rotational traverse. This is the arm body. This is the base, and if you consider this as an arm and body assembly, if you consider this as a shoulder, arm body assembly, this has a rotational traverse, and then the radial traverse. It can go inside and it can come outside. And this also have got an up and down vertical traverse is also there. So there are three motions for the arm body: rotational traverse, radial traverse, and vertical traverse. Then we have a three more wrist assemblies, where the wrist bend, and then the wrist yaw, and the wrist swivel, and the gripper will be there. Gripper is nothing but an end effector. Anything can be an end effector. Anything can be an end effector. End effector is the one which is been attached to the wrist end to do a specified task. Okay. Gripper is being used in order to pick and place operation of a robot. Now, if you consider the applications of the robots, need to replace human labor by robot, work environment hazardous for human beings, repetitive tasks, boring and unpleasant tasks, multi-shift operations, operating for longer hours without rest, assembly applications, material handling applications, and processing operations, inspection applications. So these are all the applications of a robot. This ends the complete 5 modules of elements of mechanical engineering. Thank you.